on my scientific paper titled Trading Cryptocurrency with Deep Deterministic Policy Gradients, DDPG for short. So just a quick introduction about this paper. The problem that we're trying to solve is that cryptocurrencies are extremely volatile, which makes them very hard to trade in the short term. And the safest option to trade cryptocurrencies is to buy and hold for a long period of time in hopes that the price will increase. And this paper introduces the idea of using DDPGs to trade cryptocurrencies effectively over short periods. So, quick outline on what I'm going to present today. First, I'm going to go through our high-level design. Then I'm going to go through some components and their details. Then I'm quickly going to show you some results I obtained, and lastly, my conclusion. So here, our high-level design, we can see BitMEX is the data source. So we pull down all our data from BitMEX's Python APIs. This data is then used to create some new features in the form of technical indicators. This feature engineering is done using a library called TALib. And the newly transformed data is then passed to a custom environment created using OpenAI Gym's interface. And finally, the DDPG reinforcement learning algorithm will interact with OpenAI Gym's environment to train its model. So first up, I'm just going to speak a bit about BitMEX. BitMEX is a cryptocurrency exchange that allows you to trade cryptocurrency. And this is a screenshot of BitMEX's user interface. I was a bit skeptical about putting this into the presentation, as I did not want to distract you with all of this information, but I left it in to point out how much data there actually is available to use. And BitMEX's Python API has access to all this data. As we know, the abundance of data is always an advantage when it comes to machine learning. Next up is TALib. So as mentioned, TALib is a library to transform financial data into technical indicators. Technical indicators are mathematical equations that help users predict future prices. Technical indicators, they usually take in the open price, the closing price, the high price, the low price, and volume when calculating indicators. I just have 3 examples that I want to show you to help visualize them and understand them. And first up on screen is Bollinger Bands. So Bollinger Bands is depicted by the thick blue line and the thin blue line. And the closer the price is to the thick blue line, might indicate that it is overbought, which means there might be a drop. And the closer the price is to the thin blue line means it is oversold, which might indicate a rise in price. So we can see that on screen. There is a thick blue line here. We can see the price is hovering over it, and shortly after there's a drop. And then here we can see the price is hovering over the thin blue line, and shortly after that there's a rise. So another example, which is a simple one, is the volume-weighted moving average. And this is just basically the average of all prices with volume used as a weight. And here we can see that the thin blue line tracks the price quite closely. And lastly, I'm just going to go through the moving average crossover. So this is indicated by the red and green lines. Red line we can see here, green line we can see here. Interpret this by looking at the crossovers of these lines. So when the red line crosses under the green line, it indicates that there is a drop and you should probably sell, and vice versa. If the green line rises over the red line, it means there's a rise and you should probably buy. So you can see here, red line is dropping under the green line, so there's a drop, so it's saying sell at this point. And then we can see the red line just crosses over the green line here, so that's indicating a rise in price. So next is OpenAI Gym. So OpenAI Gym is described like so on its website. Gym is a toolkit for developing and comparing reinforcement learning algorithms. It supports teaching agents everything from walking to playing games like Pong or pinball. And there are multiple readily available environments that can be used with Gym. But Jim's interface was used in this case to create a custom environment for our agent to interact with. And yeah, I just have some examples here as to what interfaces OpenAI Jim provides. We can see there are some Atari games, the classic cart pull problem, as well as a pendulum problem. So DDPGs, what are they? Deep deterministic policy gradients are an extension of other algorithms. First being policy gradients. So policy gradients are function approximators that try to optimize the parameters in said function to return the greatest reward. Now, the advantage that this function approximation has over simple reinforcement learning algorithms is that there is no need for a state action table where each state has a value for each action. And the larger your actions grow, the bigger the table grows, and it is impractical to use algorithms like this when using continuous action spaces. An extension of policy gradients is deterministic policy gradients. So deterministic policy gradients and policy gradients are very similar, only that the action space that is sampled is deterministic instead of stochastic. This helps greatly with performance. So deterministic policy gradients also bring in the concept of an actor and critic network, where the actor predicts the deterministic value of the action and the critic rates this value. And finally, an extension of deterministic policy gradients is deep deterministic policy gradients. And basically, what DDPGs do is they add a neural network to the deterministic policy gradient to allow for the consumption of a lot more data. Problem is that this brings with it a lot of instability. So DDPGs also use a few techniques taken from DPQ networks, and these are the use of a replay buffer and a target network. The replay buffer is where you sample random past experiences from this buffer when training, and the target network is where you add an extra network on top of the initial value network, and this target network is then used to update the initial network, but the update of the target network itself is staggered. So the value network is constantly updating while the target network is being updated every so often. And these two techniques help greatly with instability. So some advantages and disadvantages of DDPGs. The first advantage I seen was you can use continuous action spaces. Next, we know that they're stable thanks to the incorporation of DQN techniques. And finally, it's a deep network, so it allows the use of huge data sets. And two disadvantages I noticed, first being training times. Training times can be quite slow as data grows, and considering cryptocurrency is so volatile, I had to keep the learning rates relatively low, which it had increased training times as well. And another disadvantage was hyperparameter tuning, which can take some time, especially when doing so manually. But I did come across Optuna, which is a automatic hyperparameter tuning library, but I only saw this quite late into the project, so didn't get to play around with it as much as I would have liked to. And so these are the results I obtained in the end. The left graph shows some purchases and some sales, whereby the red dots mark a purchase, the green marks a sale, and the blue marks a hold, whereby the agent does nothing. And as you can see, a lot of the purchases were made at relatively low prices. And then on the right, we can just see the model outperforming a basic buy and hold strategy. So just to conclude, I think it is possible to trade cryptocurrency using DDPGs. I think the technical indicators were hugely beneficial. The addition of all the features helped with my training of the model. And lastly, hyperparameter tuning was probably my biggest obstacle and if I was to go back, I would look at Optuna earlier. But yeah, this is definitely something for the future. Okay, thanks for watching.